I'll have a little bit of an intervention. I guess it's been pretty formal talking up until now, but I'm an artist and I build machines. And unlike a lot of the things that have been previously talked about today, my machines are designed to fail. And they're designed to make mistakes. And they're actually inherent in their circuits, an ability to always throw surprises at me. They're all analog circuits, so by a normal scheme of robotics, you'd be familiar with the coding and predictability and algorithmic efficiency. The machines that I make throw all that out the window. So in this performance, I'll do more performing than talking, because also I can't really go over what has been spoken about today, because it's been very, very good. But the performance I'll do is with this machine that I made. It's a stringed instrument that is in a vintage briefcase that I bought from an op shop. It's a 12-string instrument that is basically a machine that composes its own rhythms by means of coding. In my way, is by chords and cables. So each port you see in the brain can be used as an input or an output. So on the whole, there are possibly thousands of ways that you could code it. And through the analog circuits, each potential connection has an ability to completely surprise me. So, in the theme of today, with machines misbehaving, this is perhaps the perfect machine to misbehave. And in an informal setting, I'll welcome you all to come up and see me try and interact with it. So there may be some apologies from me about the machine, but the machine never apologizes to me. So I'll try to fail gracefully, and you're welcome to come up and have a look. So basically what the machine is, it's all analog circuits designed around simple logic using CMOS chips. There are no microcontrollers, no coding whatsoever. Basic clock sources, shift registers, low frequency oscillators, multiplexers, and OR gates, things that make decisions depending on how you patch it. So I'll explain as I go, I guess, but you'll probably work out that this thing builds its own compositions by sampling its own gates that it produces. So I can give it a certain amount of information, but it always makes its own decisions. So first of all, I like to have a constant source. So a clock source that can be divided down along a decade counter. So from one clock source running quite fast, I can divide that down up to 2,000 times. So the main clock source is running now, going through a divider, and the divider goes to a sequencer which samples the clock and also samples a data stream from other clocks. So from that, and again, you're welcome to come up and have a look. From that clock, I can run each gate to a particular motor. So So I have the first clock running into a decade counter. 2 decade counters that go up to 2,000 times, going into a sequencer. And this sequencer chooses the outputs depending on the clock. Every time this clock fires, it samples another data input. So it can be audio, it can be voltage, it can be anything. So there's 16 outputs from this sequencer, and I can run So this is fairly basic. It's just triggering on every, wherever I patch it, it triggers on that gate being fired. I have a delay circuit that takes this sample. So for example, 1, 2, 3, 4, number 4, I can flick this off and it's a string dampener. So it's on a very short delay, so the string dampens. But I can run longer. And back to short again. Okay. So with these, it's kind of nice that they build their own rhythm, but I can add another rhythm on top. So number 4, I can add a little bit more. So every time that this light shines and this light shines, number 4 will fire. So I have rhythms on top of rhythms. So we can keep on adding up. So when I start adding all these rhythms over each other, it starts building its own . Excuse me if I'm not communicating, because I'm trying to make sure it's How do I pluck the strings? It's being struck by a piece of gaffer tape, really. But before I had some silicon plectrums that sounded much more organic. But I found that over time they'd fly off. So in a performance situation, by the end of the performance, it really didn't make any sound at all. But the good thing about that was that, the good thing about this instrument in total is that no matter how I patch it, and no matter how I program it with these chords, every time the rhythm is different. It always changes. In fact, when I take this on tour, I sometimes allow other people to play it, and even with one patch that I do, for example, as soon as another person steps in and starts playing with it, it seems to react to them just by simple switching. It seems to make its decisions all the time.
So are you improvising right now?
Yes.
Or this is a known pattern?
No, this is a complete improvisation.
Okay.
Because it's something that with the way that the circuits are designed, they're not on and off. They're using op amps, so they're judging which side of a threshold to actually sample and then fire. So depending on how you patch the whole thing, it reacts in a very different way to what you would have done yesterday or the day before. So
you can also patch the pickups into
yes. So the pickups can be run through filters. Most of this part is actually the synthetic side, so that can run the audio through filters and actually put that back in, so the sequencer can be played by itself. Depending on the audio that's coming through and filtered, you can actually alter the composition on the fly. So, let's see if we can. So we have two inputs going into this sequencer just from LFO. So if I change these, you'll probably hear a different change of the. Speed it up a bit. See, it's composing all by itself, so in this kind of situation, in a live place, I can let it go or try and interact with it. So there you go.
Why is it just suddenly got much slower?
Yes, I slowed the clock down a little.
Fantastic. Amazing.
Thanks.
Thank you.